Welcome. We are in Chapter 5, and in this video, we will look at 5c, comparing and ordering fractions. Basically, given two fractions, how can you tell which one is bigger? We'll look at a few ways to do this. We'll look at the fraction wall or length model, convert to decimal, compare denominators, compare numerators, cross-multiply, and then benchmarking. I particularly like benchmarking. It's kind of a cool mental math trick. Let's go. Number one, just an easy way if you have small fractions, and if you happen to have a fraction wall in front of you, use the fraction wall. Now, this is a good way of conceptualizing what it means for one fraction to be bigger than another. So which is bigger, 5/8 or 2/3? Well, let's see, 5/8, I look for my eighths row and I shade 5 of those. All right, so there's my 5/8. I look for the thirds row and I shade in 2/3. And I look at the total amount, and I see where those breaks line up. Oh, and it looks like 2/3 is a little bit bigger. So for a student, for a little kid, conceptually, this is a really solid way of seeing that 2/3 is bigger than 5/8. Perhaps the simplest way to compare two fractions is to convert to decimals. Just use a calculator, if you have a calculator handy. 8/23, let's see here, it turns out that this is approximately like 0.3478. And the other fraction, 11/31, you just literally plug it into your calculator, and it's approximately 0.3548. So by comparing decimals, I can see the one on the bottom is bigger, the 11/31. It's easy, but it does require technology, and it gives you no insight into why one fraction is bigger than the other. So there is a trade-off there. Common denominators. So if you compare 5/13 and 7/13, which one is bigger? 7/13. And why does this make sense? It makes sense because that denominator tells me how many parts the whole is being broken into. Perhaps I imagine two of the pies, and they're each broken into 13 pieces. And in one pie, 5 of those pieces are shaded, and the other pie, 7 of those pieces are shaded. So the one with 7 pieces shaded, well, 7 is more than 5. Now, what about 2/3 and 5/8? They don't have a common denominator, but can I make them have a common denominator somehow? I can, so let's look at this. 2/3 and 5/8. I take the denominator from one fraction, let's say 8, and the other fraction I multiply the top and the bottom by that 8. And so we've seen this idea in the past that if you take a fraction and you multiply the top and the bottom by the same number, you get an equivalent fraction. So this becomes 16/24. Now what will I do on the right? To get the same denominator of 24, now I need to multiply by 3/3. 3/3. This gives me the fraction 15/24. Now I have common denominators. So you can take two fractions and force their denominators to be the same, 24/24, which tells me that I look at the numerators and the 16 is greater. So 2/3 is greater than 5/8. What if I have common numerators? How would you compare 3/10 and 3/4? What do you think? Well, again, maybe we consider two pies, so two wholes, and the first one is broken into 10 equal parts, and the other one is broken into 4 equal parts. And in the first case, I'm just shading 3 of those tenths. And in the second case, I'm shading 3 of those fourths. And it stands to reason, the fourths give me bigger pieces because there's fewer of them. And so if I shade 3 of them, I'm shading in 3 bigger pieces. Whereas the tenths, there are more tenths, so each tenth is smaller. So if I shade in 3 of them, I'm shading in 3 small pieces. So that kind of reasoning can lead us to understand that if two fractions have the same numerator, then the one with the smaller denominator, that actually makes a bigger fraction. How about cross multiply? The trick here is I write down the two numerators in the same order, so the 7 and the 3, and then I multiply across. So that 9 gets multiplied times the 3, so 3 times 9, and the 4 gets multiplied times the 7, 4 times 7. And I see what those are. So in this first case, I have 28. In the other case, I have 27. 28 is greater than 27, so I conclude that 7/9 is bigger than 3/4. Why does this work? Well, maybe you can see it. This really is basically the same thing as common denominator, right? Let's do this same problem again, but finding a common denominator. 7/9 and 3/4. What would I do to get my common denominator? Oh, on the left, I'd multiply times 4 over 4. Ah, you see how I had that 4 there earlier? And on the right, I'll multiply times 9 over 9. Ah, there's that 9 that I had before. So when I simplify on the right, 27 over 36. On the left, 28 over 36. And I know that my two denominators will be the same. So it's almost as though the denominator doesn't matter. What I'm really looking at to determine which is bigger is the numerator, the 28 or the 27, and the 28 is bigger. With cross multiplying, with this process, we sort of ignore the denominator because we know it's going to be the same in both sides anyway, and we just focus on figuring out what those numerators are. Benchmarking. This is a cool mental math trick. The idea is, if I have two somewhat complicated fractions, maybe they're somewhat close to a easy fraction. So, like 5/12 and 11/20, it turns out both of those are pretty close to 1/2, and 1/2 is a nice, simple, easy fraction. In fact, let's see here, what is 1/2 in terms of twelfths? 1/2 would be 6/12. And in the right, in terms of 20ths, what is 1/2? That would be 10/20. So I can see that my 5/12 is a little bit less than a half, and 11/20 is a little bit more than 1/2. So these two fractions live on either side of 1/2, and 11/20 is a little bit more than a half, so 11/20 is bigger. How about these two fractions, 11/30, 31/100. Both of these are kind of close to 1/3. In fact, what is 1/3 really? So that would be 10/30 is about a third, is exactly a third. On the right, well, that one's a little tougher. Something like 33.3 over 100, that's about a third. And now I can see 11/30 is just a little bit bigger than a third. And on the right, 31 out of 100, that's just a little bit less. So 11/30, that's the bigger number. How about these two fractions? Take a second and think about these. Can you see which one is bigger? What's my benchmark? All right. So the benchmark in this case is 1. They're both pretty close to 1. But neither one of them is bigger than 1. They're both a little bit less. So in fact, how can I determine which one's bigger? 33/34 is just 1/34 away from being 1. And 99/100 is just 1/100th away from being 1. So this first fraction, 33 over 34, is really, I can think of that as 1 minus 1/34. It's almost 1, it's just 1/34 shy of being a 1. And the 99/100, that's the same as 1 minus 1/100th. And maybe this helps us see which is the bigger number. Subtracting off a 34th is subtracting more than subtracting off a 100th. 100th is pretty small, and the 1/34 is bigger. So if I subtract less, that gives me the bigger fraction. So 99/100 is bigger. Here's another one. Pause the video, see if you can figure this out, and then start the video again when you want to check your work. Go ahead and give it a try. All right, we're back. So in this one, I'll say that 1/4 is the benchmark, and they're pretty close to 1/4. In fact, what does 1/4 look like? In terms of 40ths, 1/4 is 10/40ths. And on the right, 9/32. In terms of 30 seconds, 1/4 is 8/32. So this 11/40ths is just a little bit more than a fourth, and 9/32, that's a little bit more than a fourth also, but how do they really compare? So 11/40 is like 1/4 plus 1/40. So I have my 10/40 plus 1/40. And the 9/32, well, again, that's like 1/4, but how much am I adding here? I'm adding 1/32. So which is the bigger number? In the first case, I'm adding a 40th. In the second case, I'm adding a 32nd. Oh, you can even do comparing fractions that have equal numerators, and the one with the smaller denominator is the bigger fraction. So 1/4 plus a 32nd, that's bigger than 1/4 plus a 40th. So 9/32 is the bigger fraction. Here's one last question I'll leave you with. This was the fraction that we saw when I said you could just plug it into your calculator and find the decimals. But now, maybe think about benchmarking. Can you do some mental arithmetic and convince yourself which fraction is bigger? All right, I will leave that for you to give that a try. But in this lesson, we've looked at some different techniques for comparing fractions, and in particular, take some time and think about this benchmarking technique. If you can get good at it, it's a nice, quick way of really understanding fractions and doing some nice mental arithmetic.